Right, Mr. Palmer back again. Third video in the little artificial intelligence series playlist. So this is about neural networks. So basically, what you want to know think about is how do neural networks learn, where are they used, and what are the limitations of neural networks. And you want to be able to compare and contrast this actually with knowledge-based systems. So we normally think of computers as input, process, output, storage. All right. A knowledge-based system basically is kind of working along the same lines. You input in some answer to questions that's processed using the database, and then you get some kind of output basically based upon the processing that's taking place via the inference engine. All right. Neural networks are on a different kind of line, so they're modeled on human characteristics. So what we're trying to assume is that the computer can learn, and if the data in the environment around the computer changes, then the computer applies what it has previously learned to draw new conclusions based upon the data that it's now receiving. So if you think about neural networks, they're kind of like trying to be modeled upon the human nervous system, where you have neurons that are connected together, and as you learn things, connections are formed between new neurons, and the more you repeat a process, the stronger the connection comes along a particular neural pathway. All right. So in a neural net, you have nodes instead of neurons, and the nodes are connected to each other. You have input nodes which feed data into the neural network, into the neural net, and you have output nodes which present you with a result based upon the connections inside the neural network. So basically, the nodes in the middle, they're the processing nodes. All right. So the connections between nodes have different weights. This is similar to the concept of neural networks in our brain, where the more you repeat an action, the stronger one particular pathway becomes. So if you think about the neural network that you can see in front of you right now, A and B are both connected to node D. If A and B are both receiving input, both of them are going to send a signal to node D. But what value will D take? The answer is it takes on the value of A, because A has a stronger weighted connection to it than B. So E is in a similar boat because B and A are both connected to it. So if A and B are both triggered, then it's going to take on the value of B, because B has a stronger connection, or the connection between B and E, the two nodes, has a stronger weighting. So if we have a particular question, we know that particular question has a particular answer. All right. So what we start to do is we can basically feed our neural network with data, okay, and then the question, and then we get an answer at the other end. And then based upon the answer, the neural network will then train itself by propagating the error through the network and adjusting the weights of different connections. All right. And basically that's what happens. It keeps trying a set of data until it arrives at the correct conclusion, at which point it then moves on to the next set of data, tries that with the conclusions that it reached in terms of weightings with the previous set of data, and tries and sees if it reaches the correct solution for this new input set. And if that's wrong, it propagates the error through, and it will try and retrain itself, and it keeps doing that until it can basically handle a set of inputs and arrive at the correct answer to that problem. You should be able to see a problem with this in terms of it takes ages to train a neural network. All right, so it not only does it take time to train, it also takes a lot of time to program it, and often neural networks can operate as a black box, because we know that if we're putting an input in, we're getting an output, and we seem to be, after a certain period of time of training, receiving the correct outputs. But actually, how is the neural network working within? We may actually not know. Excuse me. Neural networks can be applied in many different ways. We use them for character recognition. When you, for example, OCR, handwriting recognition, ANPR, can be used for image recognition, because pattern recognition is a very good application of neural networks. You may have had a go already at Google Draw. Okay, so you can just do like Google Draw AI, Google it, and it will take you to this thing, and you can have a play with it. And they use a neural network, and they've got like millions of people basically been playing this game, and they've been training Google's AI network here, neural network, to learn to recognize images that are being drawn. It's worth having a go with it, and you can see basically how good or bad a neural net can be, right? Neural nets are actually quite good at solving limited size traveling salesman problems. Once you get beyond a certain size, they can't really cope with it. Electronic nose, so sniffing things to identify whether they have, for example, contraband substances within them, etc. As replacing, for example, a dog, a sniffer dog. Okay, so you should be able to actually say what is your network and how they function, and you've got some ideas of where they might be used, but you also can see the limitations of a neural network. So, in terms of the time it takes to train them, and they may not even be successful after the training process. Okay, so final video summarizing the whole thing coming up.